Hello, Chem 1A. This video is going to provide the procedure and background information for the alum experiment, wherein we determine the empirical formula of a alum salt. As with all experiments, the first things I want to talk about is safety. We have the safety goggles that have been provided to you. You do need to wear them. There is a portion of this experiment where some of the alum could come out of the aluminum tin that we'll be seeing and present a potential eye hazard. A particular note with this experiment is the hazard of touching or holding on to hot objects. So later on, you're going to see me use these clamps to hold on to an aluminum tin so that you don't have to handle it because it is hot enough to burn you after it has been heated. I think that's obvious enough. This I'm touching now, which of course I can do because it hasn't been heated up, but this will stay hot for several minutes after heating. Of course, the source of the heat is this container of what I may refer to as sterno. It's a common name for it. If you pick yours up and kind of move it around, you can feel the liquid sloshing around in there. That is, of course, the fuel. And for that reason, well, I'm not going to do it. You don't turn them upside down or on their side. It could result in some of the fuel leaking out, which would be a problem. The other thing I'm going to do right now is I'm going to open this up. There we go. And of course, you see the wick, or at least I believe you can see the wick on there. And you can see this flame rather obviously. And I've lit that. You might not be able to see the flame. It is a very faint flame, but it is still a rather hot flame. So just be aware that just because it's lit doesn't mean that you're going to be able to see it. When the time comes out to extinguish the flame, just put that right over the top of it and it will put that flame out promptly. Let's see, what else might I say about safety? Yes, the procedure calls for a pie tin. It doesn't have to be a pie tin. As you can see, I've used a baking tray. The purpose of this is simply to hold everything that might spatter out, as there is a potential for some of the material to spill. So anything that you've got, if you want to use some aluminum foil, that's fine as well. The point being is, there is a potential to create a minor mess, and you want to make certain that you've got something to be able to clean all of that up. I'm going to take that off of there, and you can see, of course, that the flame is out, and I'm going to put that back on and put it back on when I need it. The next thing I want to talk about is handling the scale. So this is the scale. It may not look exactly like this. There's a couple of different versions. And on the back of it, of course, is where the batteries go. This top on it protects the balance pan. This is really rather sensitive. I know this is not an exceptionally good scale, but it meets our surfaces. If you put a lot of force on that with your thumbs or anything else, you'll damage and ruin the scale and won't be able to use it for any of our experiments. So I'm going to put that back on there because now, pardon me if I get here, you can see I'm pushing on it with my thumbs, and on this side, I'm pressing on the cover and not on the balance pan. So I do that to remove the back of that to get the batteries going. So again, if I were to do that and were to be pushing on this while I took the battery cover off, again, you'd almost certainly damage the scale, and we simply wouldn't be able to get another one. So that's a few comments on the scale. So that being said, we are ready to begin the procedure. And this is what you're using. And note, this just says alum crystals. Alum is a generic name or a common name, if you will, for alum. And the alum comes from the fact that it's got aluminum in it. But again, don't confuse alum with aluminum. A particular note, the alum that we're using has that formula, or that generic formula, potassium aluminum sulfate. There are multiple different forms for potassium aluminum sulfate, or specifically multiple different empirical formulas for it. So when I bring that back there, you can see in this formula, I put X molecules of water. It is the empirical formula, or the value of X in that formula, that we are seeking to obtain in this experiment. We are going to do that by measuring out some alum, heating it up to remove the water, weighing it again or determining the mass again, and determining by difference how much water was liberated. And if we know how much alum we started with from that data, we can determine what the empirical formula is. Okay, so let me get this started. I'm gonna take my lid off, put it off the side, safety glass is on. In goes the sterno to get that set up. I have one of the aluminum tins that I'm going to be using. Now they're absolutely clean when you start with them, so there's no particular need to dry them out. I've got my balance with the batteries already in it and the plastic wrap taken off. Let me get this turned on. Now I'm going to show you the measurement. Of course, the measurement is 0.00. Now I'm not going to be able to show you the balance later because I'm going to be weighing something on it. But note that it does have different measurement scales. That one's in ounces. That one happens to be troy ounces. My point is there's different units on there. You want to make certain that you are measuring things in grams, and all measurements, even those which end in 0, must be recorded. So that would be written as 0.00 grams, not simply 0 grams. So I'm going to set that there. I have my aluminum container, and pardon me, I realized that I forgot one thing, so let me mention it now. Before you actually begin your experiment, you should of course have your laboratory notebook out. It should be prepared in the manner in which we've discussed via the handout that I sent out. Specifically, it needs a date, title of the experiment, brief objective, et cetera, and particularly importantly for this experiment is you need to have prepared a data table or at least a place where you are going to collect the data. Recall that you do not erase anything in the lab book. You do not use whiteout in the lab book. You write everything that you observe during the experiment in the lab book while you are doing the experiment. Writing things down on loose sheets of paper and transferring them to the lab book at a later time is simply not acceptable. So with that detour, I'll come back. I've got my container. I put that on there because I need to know how much it weighs empty. And again, I can't show it to you. You'll just have to take my word for it that the measurement is 5.21 grams. The experiment calls for, again, the potassium aluminum sulfate, and the procedure says 2.00 grams. I am changing that. Pause for this to step in. I am changing that. I want between 1.90 and 2.10, but specifically not 2.00 grams. Okay, so I've got some of the potassium aluminum sulfate. You have the spatula, and we transfer into the aluminum container until we get to that range that I've asked. Now, I just said, excuse me, that I want between 1.90 and 2.10. So if the aluminum container is 5.21, that means if I add 1.9, I get 7.11. If I add 2.1, I get 7.31. So I'm looking for a mass between 7.11 and 7.31. And looking down there, I see looks like I got fortunate, I see a mass of 7.23 grams. So I'm very much in the range that I was looking for. Okay, that goes on the balance pan. I've got my flame. I'm going to heat that up, and you should have a timer. It's not real critical in terms of the exact amount of time, but it does require heating for 5 minutes. So while this is heating, I'll continue to talk a little bit. You will be able to look in there and you'll see rather quickly changes being made. I don't know if you can hear it on this video, but there's some crackling and popping noises that are going on. That will go on for the first minute or perhaps two. What is occurring is that the water of hydrate, right? That's to say the water in that formula is being liberated, or perhaps you could use the word released. Please do not use the word boiled. Boiled is something that happens with liquids. Liquids turn from the liquid state to the gas state, and that phrase is called boiling. Here, the molecules of water are locked into the crystal structure, and they are being released as steam. I don't know if you can see the steam coming out of it. You certainly will be able to when you do yours. The other thing that you'll be able to see is a change in structure. I think I mentioned this before, but again, if you look at that, you can see there's a crystalline structure to it. That is to say, you know, they look like cubes. And if you looked at it under a microscope, you could see even more defined crystal structure. After you have heated it, that crystal structure goes away, and at least by observation, it's going to look amorphous. Given the volumes that we're, or the masses that we're working on, you may not see that real well, but trust me, that is occurring. So this continues to heat and heating, and again, you can't see that. I can't quite show it to you, but it's continuing to heat. It's been about 2 minutes now, so we're going to let this heat for, again, the full 5 minutes. I'm going to put my screen down. I'm going to come back in 3 minutes. If you'd like, you can fast forward your copy of this Zoom session forward about 3 minutes until I come back. So shutting things down for a moment. Okay, I'm back. So at this point, it's been heating now for about 5 minutes, and we need to cool it off. Now, you might, if you want, have something to help you push this out of the way. And again, this is why it's important perhaps to have something that you're doing it on. As I said, If you were doing this with the pie tin, you probably wouldn't have quite enough room. And I put that out. Now this, it's a little bit warm, but certainly can be touched as I am doing it now. This, however, is very hot. So do not touch it. That will, of course, burn you quite rapidly. And even if you could touch it, which again, I'm not suggesting you do, you'll note, of course, this is aluminum or metal. It's hot. The balance lid is plastic. If you transfer it directly onto there, two bad things will happen. You'll, of course, melt the balance lid, which is a problem because it might stick to it, and then you can see that that would be a problem. The other thing that will occur is since this is very hot, the air currents, because it's hot, rise up. And those air currents that are rising up creates a buoyancy that could reduce the mass of the object. Given the precision of the balance we're using, that might not occur. If you are using an analytical balance, like I demonstrated a couple of weeks ago, that reads to the nearest 1/10 of a milligram, that is certainly a potential problem. So we're going to allow this to cool off. And so the procedure simply says to allow it to cool for a few minutes. I don't know that there's an exact amount of time, but I'm going to give it an additional 2 minutes. I note that, you know, the back of your hand is very sensitive to heat, and I can feel heat coming off of this, and I really don't want to put it onto the balance pan until it's cooled off. So I'm going to lower the lid again, turn this off, and I will be back in 2 minutes. You can fast forward your video. Those are mine. Okay, I'm back. Again, you know, I can't sense any heat coming off of there. I still don't want to touch it, just in the event that there's a little bit of heat remaining. Grab onto that carefully. If you're not careful, it'll kind of flip around and come off. So I've got my aluminum container. I put it on the balance pan, and I have a measurement of 6.13 grams. Now at this point, I look at it, and it still remains a white solid. It was a white solid. The intent was to remove all of the water, but I have no way of knowing if all of the water is being removed. I don't have X-ray crystallography vision, and so I can't look into that material to see if all of the water has been released. The common method of determining that is to heat it again. And when the mass doesn't change or is within an acceptable limit, we conclude that all of the water has been released. That is not, strictly speaking, correct in all circumstances, but for this particular salt, we can be confident that if upon multiple heatings, the mass doesn't change, that we have in fact released it all. So I'm putting that back on there. Perhaps I should have used the clamps. I put that back on there. That goes back in. So I'm going to heat it again. lights, of course, rather quickly. I should point out that you do want to make a point of turning off the flame, as we may need this for a few experiments and I don't want you to have to run out and get another one. Now at this point, I'm going to accelerate the video because these next steps are, again, just repeats of the previous ones. So at this point, you heat it for an additional 5 minutes. And at this point, I am, if you will, going to kind of presume some numbers. So we heat that for 5 minutes. So again, let's just pretend those 5 minutes went by. Let me get that out of the way, put that back on there. Again, I need to wait for this to cool off again. And so now I'm simply going to give you a couple of numbers as if we had heated this the full time through. So after the second heating, right, after I've heated it up, still a little bit hot, I'm not going to put it on the balance pan. So we'll sit here and look at each other while we wait. Let's see, what else might I say? I didn't specifically say it, but you're working with a flame. If you have long hair like me, make certain you've got it tied back, put it in a ponytail, right? The smell of burning hair really is a very, very bad smell. It usually portends some injury, but even if there is no injury, the smell is really bad. So please make certain that you've got your hair tied back. And again, the other thing I'll comment about safety is, I know many of you are space constrained, you're in circumstances that may not generally provide you a lot of space, but this experiment particularly does need some space, right? If you're working very cramped with a flame, I think you can understand how that could be a potential problem. Obviously, a kitchen works well, you know, a garage works well if you've got it, but you do need to give yourself some space. Okay, so I'm gonna put my hand on, there's still some warmth on that. I didn't heat it for very long, but there's still some warmth on that. So I'll wait for another moment. In the next video that I'm going to show, or perhaps we'll do it during class, I'm going to show you how we take these numbers to calculate the end result. But this Zoom session is really just about the procedure. So again, I put there my hand next to it. There's no heat coming off of that. So I grab onto that. Back onto the balance pan. And write down in my notebook, I have a mass of 6.09 grams. 6.09 grams. Now, the previous measurement, or the first, I should say the measurement after the first heating was 6.13 grams. So the mass has come down by 0.04 grams, which is a definite indicator that the first time through on the heating, I didn't get all of the water out. So we heat it again, I got 6.09 grams. But we still have to ask ourselves the same question. How do we know all of the water has been released? And the answer remains the same. We don't, right? How do we know if we heat it again, the mass may simply not come down again? So this is an additional part of the procedure. The procedure calls for 2 heatings. I want you to continue heating until 2 consecutive measurements agree to within 0.03 grams. The first 2 measurements did not agree to within that interval. They agreed to within 0.04 grams. So we heat again. All right, so I heat that again. And again, for sake of time, we're going to assume that I've heated this for 5 minutes. It's kind of like those cooking commercials, right? They throw something in the oven, go to commercial break, and then they say after it's been heating for 30 minutes, comes out of the oven looking wonderful. So we're going to pretend that we're in one of those cooking shows. I'm going to take that out, presume that I have heated it for a full 5 minutes. And now, since I literally have heated it, I have to let it cool off, lest it melt the balance pan with all of the problems that we've discussed. Let's see, if we were in class, I'd stop right here and ask if you have any questions, but can't quite do that. So again, these things heat up rather quickly, and we do have to wait for them to cool off. So I'm going to let that cool off a little bit, kind of running out of things to talk about. So, pardon me, going to continue to wait. When you heat it for 5 minutes, obviously it heats up to a much greater extent. Let's see, let me talk a little bit about the balance. Again, obviously they're not exceptionally expensive balances, but nor are they particularly cheap. If you drop them, they will go out of calibration very quickly, or you'll disrupt the internal electronics. So do store them in a place where you're going to be able to prevent them from getting knocked around. I haven't used all of the aluminum sulfate. When you're done with this experiment and after you have confirmed that your results are acceptable and after you have submitted the report, then the alum crystals can simply be flushed down the drain. All of the materials that we're using in this class are such that they present no hazard short of potentially eating them, which of course you won't be doing, and can properly be flushed. Okay, so no heat emanating from that. I use that and again, grab onto it rather carefully, transfer it to the balance pan, and I observe a measurement of 6.10 grams. Okay, now if you recall or were writing down, the previous measurement was 6.09 grams. So how can it be that the mass went up by 6.10 grams? Well, that can happen in a number of different ways. One, the balance itself is not exact, right? This is all what we've been talking about measurement. So you can get some fluctuations, especially in that last digit. So that fluctuation in the last one may simply be a little bit of random fluctuation or random error associated with the use of the balance. The second thing that may occur or could have occurred is that maybe there was some dirt or some such thing on this heating mesh that adhered to the aluminum container. And so when I transferred it the third time, maybe it stuck. And so maybe the mass actually did go up as a result of transferring, right? 1/100 of a gram really isn't that much, and that's certainly possible. A third possibility is this. Potassium aluminum sulfate, when it has no molecules of water, right? So here's the structure, pardon me, let me put my hands. That compound all by itself, which largely is now in there, absorbs water from the environment. I know we've got people all over the globe. If you live in a particularly humid environment, especially on a warm day, some of that moisture in the air can be absorbed directly into it. So in some situations, just the amount of time that you're letting it cool off can result in some of the moisture being absorbed back into it, thereby increasing the mass. So again, there's all kinds of potential reasons for the mass to have gone up. And in this case, it went up by 1/100 of a gram, which is my point that I want you to continue until 2 consecutive measurements agree to within 0.03 grams. When that has occurred, we will simply presume that all of the water has been gone. And I'm going to repeat this again because it has been my experience that some students just have a hard time grasping the idea that it could have gone up. It can, it will. I want you in the calculations to use the last measurement. In my case, that is 6.10 grams, right? Not the lowest measurement, not the one that you think will give the correct results, but the very last measurement that can be taken. Okay, so at this point, we're now done with the experiment. So let's talk about cleanup and safety again. Again, leave these sit for several minutes so as to become completely cool. This cools off immediately, or I shouldn't say immediately, cools off very quickly. So allow it to cool before you handle it. Again, this is already cooled. So at this point, these materials can be simply washed down the drain. It may be difficult to remove all of the alum salts from in there. That is to say, they may not want to wash out quickly. It's not really necessary. I recommend that you maybe write on the bottom of it what's in there, the alum crystals. We may need these a little bit later. So go ahead and hold on to these. Don't worry if you can't get all of the stuff washed out of it. Maybe you'll just let some water sit in there overnight and it'll probably dissolve. I put the top back on that. And again, always leave it upright. Don't leave it on its side, or certainly not upside down. And at this point, looking around, checking, we're all done. Just wash everything else up with soap and water. Of course, wash your hands with soap and water. And in a subsequent video or in class, we'll walk through the calculations using this data.